Alrighty, on to problem 3, and now we're finally going to utilize some of our integration techniques that we've learned. One being, U substitution. But we'll get to that later. But we'll see quickly why we're going to need to use it. So first off, we need to set up the integral. But this time we're given bounds between 0 and square root of pi. So we have our a, we have our b. So we have a curve 4 sine x squared, and the x-axis x equals 0. So the radius is going to be x once again. So let's zoom in here. Volume is our 0 to square root of pi. We have our 2 pi. So that's how WeBWork wants it. Then we have our radius, so times x, and then times our curve, 4 sine x squared. And now just writing that, we can see why we need U substitution. We have an x multiplied by a trigonometric function, and then inside of it we have an x squared. And as I've said in the previous homeworks, when looking to choose what U, you're going to look inside parentheses, trig functions, exponentials, denominators, and square roots. Well, right here we have a perfect x squared we're going to use for U. But for right now, this is part 1 completed. Now we're going to move on to that integral down here. So first off, I'm going to make it easier by taking out all the constants. We have a 2 pi, and we have a 4. We have a 4 we're taking out as well. So 2 pi times 4 is 8 pi. 8 pi. And we have an integral 0 to square root of pi. Oh, yeah. Let's just write it down. 0 to square root of pi. And we have x times sine x squared dx. And we're going to let u equal to x squared. Perfect. And that means du is equal to 2x dx. We're going to divide by 2 either side. And we're left with x dx. Cancel out an x, cancel out an x, cancel out a dx, cancel out a dx. And pull out that 1/2 in front. And we're given 4 pi, 0, and new bounds. It would be, let's see, so we have square root of pi squared is pi. So we have u of square root of pi is equal to square root of pi squared, which is just pi. And then u of 0 is just 0. So we have 0, 2 pi of sine of u du. So now we have integral of sine is negative cosine of u from pi to 0. And we know now we have this. So let's write it down. Give me 1 second, my pen's not working. Okay, here we go. Cosine of pi minus cosine of 0. And we have cosine of pi. It's negative 1 times negative is positive 1 plus cosine of 0 is just 1, so it's 1. So we have 2 times 4 pi. That's equal 8 pi. That's our volume for question 3 using U substitution. For once, we're not using power rules.